Today we're going to be looking at some synthetic division of polynomials. Now, we were all familiar with the algebraic division of polynomials. I'll make a video on that too. But there's kind of a shortcut and faster way to do so, solving these questions. So for example, let's say we have a question where we have a polynomial of 2x to the 5 plus 7x to the 4 plus 5x cubed minus 5x squared minus 7x minus 2. Let's say all of that equals f of x. And the question is to factorize it. Now you can pause the question here, pause the video here, and try to answer the question. Let me write it out a bit cleaner. And yep, there. You can have a go at answering this question. Great. Now that you're back, we will use the synthetic division method to solve this question. So first, we either plug in some simple numbers, such as x being plus or minus 1, or plus or minus 2, etc. And by doing so, when we plug in f of 1, we find that equals 0. Because up above we basically get 2 plus 7 plus 5 minus 5 minus 7 minus 2. 5's cancels, 7's cancel, 2 cancels, we get 0 overall. So if you spotted that, well done. But now to get to the meat of the video. If we know that f of 1 equals 0, then by factor theorem, x minus 1 has to be a factor. So we set up our synthetic division method, we put our factor outside, f of 1, then we take the coefficient of each x variable and its exponent, respectively, and we put it inside here, this sort of reverse bus stop. Long division is often referred to as the bus stop method, but this is synthetic division. And let's just take all these coefficients and put them down below, including this constant of minus 2. So we put in 2, 7, 5, minus 5, minus 7, minus 2. Let's bring down the 2. We have 2 here. Now, with whatever result we have on the bottom, we multiply it by our factor. And our factor in this case is 1. So 1 times 2 is 2. And whatever we have inside our little bus stop here, reverse bus stop, we add. 7 plus 2 is 9. 9 times 1 is 9. 9 plus 5, 14. 14 plus minus 5, 9. 9 times 1, 9. Minus 7 plus 9, 2. Minus 2 plus 2, 0. Usually, at the end here, this is our remainder, our r of x, but as you can see, r of x equals 0. So that means we'll be able to divide through perfectly and cleanly. And what do these results here on the bottom mean? Well, we can essentially now say that x minus 1, our initial factor, multiplies by our new factor, of 2x to the 4, the next degree lower than 5, because remember, we've just divided by x. So when you divide x to the 5 by x, you have to go to the next smallest thing, which is 4, the degree of 4. So our next one is cubed, then squared, then x, then a constant. So this here would be your final answer. Sorry it's kind of messy, but this is how quick synthetic division can be. It just spits out the answer to you, especially when there's no remainder. So in this question we were lucky not getting a remainder, but let's try a problem where we do get a remainder and see what happens. Now for our next problem, we have a longer polynomial to the power of 8, the degrees to the 8, minus 4x to the 7, plus x to the 6, plus 12x to the 5, minus 9x to the 4, minus 12x cubed, plus 11x squared, plus 4x, minus 4. Factorize by x plus 2. That's the question. You can have a go and you can come back and check your answer. Now, let's solve the question. So let's set up our reverse bus stop. We know that x plus 2 is our factor. So in this case, f of minus 2 has to equal 0 according to factor theorem. So outside, we just put a minus 2. And on the inside, we put the coefficient of each x term variable. So we had 1, minus 4, 1, 12, minus 9, minus 12, 11, 4, minus 4. So let's start the process. 1 times minus 2 minus 2, that makes minus 6, that's 12, that's 13, that's minus 26, that's minus 14, that's 28, that's 19, that's minus 38, that's minus 50, that makes a nice 100, that's 1, 1, 1, it's even more satisfying, that's a minus 2, 2, 2, that's a minus 2, 1, 8, and right at the end here we have our remainder, or what's going to be our remainder, and we have a 4, 3, 6 up above. So on the bottom we have a 4, 3, 2. Sorry it's kind of squashed. So what does this mean for our remainder? Our remainder is no longer 0. So it doesn't divide through cleanly anymore. So when writing up the full form, we keep the x plus 2 and we keep this quotient right here, q of x. I'm just going to write it as q of x, leave it there, plus our remainder all over our original factor. So in this case, we would simply just have 432 over x plus 2 as our remainder. And this is the final full form of what you should answer when asked to factorize a high degree polynomial. Thank you for watching the video, and goodbye.